Imagine looking up at the night sky and realizing that among those countless stars, there are worlds so much like our own, places where oceans might ripple under alien suns, where mountains could rise against strange horizons, and where life, in forms we can barely fathom, might already be thriving. The universe is almost unimaginably vast, with billions upon billions of galaxies, each home to even more stars, and orbiting those stars, planets beyond number. Yet for all that staggering scale, one question has haunted humanity for centuries. Are we alone? The answer might be closer than we think. Scientists have discovered thousands of exoplanets, worlds beyond our solar system, and among them, a handful stand out as eerily familiar. These are places with conditions so strikingly similar to Earth that they could, just maybe, cradle life of their own. Today, we're setting off on a journey to 25 of these extraordinary worlds. Picture planets where the air might be breathable, where liquid water could pool on the surface, and where the ingredients for life as we know it are all in place. Some orbit in the perfect zone around their stars, not too close, not too far where temperatures are just right for water to flow. Others have atmospheres thick with gases that hint at the possibility of something stirring beneath their clouds. A few even have days and nights, seasons and weather, mirroring the rhythms of our own world. These aren't just dots of light in a telescope, they're real places with real potential to rewrite everything we know about life in the cosmos. What makes these discoveries so thrilling isn't just the science, it's the story they tell about our place in the universe. Every time we find another Earth-like world, it's a reminder that we might not be the only ones asking these questions. Could there be civilizations out there gazing up at their skies, wondering if they're alone, or simpler life forms just beginning their journey? The search for these planets isn't just about cataloging distant rocks, it's about uncovering the possibilities of existence itself. So let's dive into these 25 alien worlds, each one a tantalizing clue in the greatest mystery of all. Are we truly alone in the cosmos, or is life out there waiting to be found? Kepler 186f is the first Earth-sized planet we've ever found in the habitable zone of another star, a place where temperatures could allow liquid water to exist on its surface. Think about that for a moment, a world roughly the size of our own, bathed in just enough warmth to keep water from freezing into ice or boiling away into steam. But this isn't a twin of Earth, it orbits a dim red dwarf star, much cooler and smaller than our Sun, casting a perpetual crimson glow over its landscape. If you stood on Kepler 186f, the sky would be washed in hues of deep red, with its star appearing only about half as bright in the sky as our Sun does at noon. What makes this planet so fascinating isn't just its size, it's where it sits. The habitable zone around red dwarfs is much tighter than around stars like ours, meaning Kepler 186f orbits much closer to its star than Earth does. A year there lasts just 130 Earth days, but because red dwarfs burn so steadily, this planet could have had billions of years for life to emerge, far longer than Earth has existed. Scientists suspect it might be tidally locked, with one side always facing the star in eternal daylight and the other shrouded in endless night. Yet even in such extreme conditions, life could find a way. The twilight border between scorching day and frozen night might offer a temperate strip where liquid water could pool, and atmospheric currents could distribute heat, creating environments where life as we know it might cling to existence. Then there's the question of water itself. While we can't yet confirm if Kepler 186f has oceans, its position in the habitable zone makes it a prime candidate. If it does, if rivers flow under that alien red sun, then every ingredient for life could be in place: carbon, nitrogen, energy from its star, and most crucially, liquid water. It's a tantalizing thought. A world so similar in size to ours, just 500 light-years away, could be home to something, or someone looking back at the cosmos, wondering the same things we are. Just a cosmic stone's throw away at 4.2 light-years, Proxima Centauri b is the closest known exoplanet to Earth, so close that in astronomical terms it's practically next door. Imagine stepping outside on a clear night and spotting Alpha Centauri, the closest star system to our Sun. Nestled within that system orbits this intriguing world, a prime candidate in our search for extraterrestrial life. But proximity alone doesn't make Proxima Centauri be special. It's what we've uncovered about this rocky planet that sparks the imagination. Roughly 1.3 times the mass of Earth, it basks in the faint glow of its red dwarf star, Proxima Centauri, a star so dim that even at close range, this planet receives only about 65% of the energy Earth gets from our Sun. Yet here's the twist: despite its cooler star, Proxima Centauri b might still be warm enough for liquid water. If it has the right atmosphere, scientists speculate that a thick, insulating blanket of gases like carbon dioxide could trap heat, creating a greenhouse effect strong enough to compensate for the star's weakness. But this world comes with its own set of challenges. It's almost certainly tidally locked, meaning one hemisphere is baked in perpetual daylight while the other is frozen in eternal darkness. Sound inhospitable? Not necessarily. The boundary between these two extremes, known as the Terminator line, could host a twilight zone where temperatures are just right. Picture a narrow band where the sun forever hovers near the horizon, casting long shadows across a landscape where rivers might flow under a sky streaked with unfamiliar constellations. Then there's the star itself. Proxima Centauri is a flare star, prone to violent outbursts of radiation that could strip away the planet's atmosphere over time. But life, if it exists here, might have found clever ways to adapt. Subsurface oceans could thrive beneath icy shells, shielded from the radiation above. Or perhaps hardy organisms have evolved to harness the energy from these stellar flares, turning a potential death sentence into a power source. The tantalizing possibility of an atmosphere also raises another question. Could we detect signs of life from here? With next-generation telescopes, we might soon analyze the chemical fingerprints of Proxima Centauri b's air, hunting for molecules like oxygen or methane, hints that something stirs beneath those alien skies. What makes this planet so compelling isn't just its potential for life, but the very real chance that we could one day reach it. Breakthrough Starshot, a visionary project, aims to send tiny probes hurtling toward the Alpha Centauri system at a fifth the speed of light, arriving within decades. If successful, we might get our first close-up glimpse of this neighboring world, a blurry image perhaps, but one that could change everything. Proxima Centauri b isn't just another exoplanet. It's a testbed for our boldest dreams of interstellar exploration, and a reminder that the answers to humanity's oldest questions might lie just around the cosmic corner. TRAPPIST-1e isn't just another exoplanet, it's part of one of the most fascinating planetary systems we've ever discovered. Picture this: a single, faint red dwarf star, barely larger than Jupiter, with not one or two, but 7 Earth-sized worlds orbiting it in a cosmic dance. Among them, TRAPPIST-1e stands out as a prime candidate for habitability, a rocky world bathed in the perpetual crimson light of its tiny, cool sun. What makes this place so remarkable isn't just its size or composition, it's the sheer potential for liquid water. Scientists estimate that TRAPPIST-1e could have vast oceans, perhaps even more water by proportion than Earth, with its surface possibly covered in a global sea. The star itself is a quiet, long-lived red dwarf, emitting just a fraction of the energy our Sun does. But because the planet orbits so close, completing a year in just 6 Earth days, it still sits snugly within the habitable zone. Standing on its surface, you'd witness a sky dominated by the deep red orb of its star, casting an eerie glow over landscapes that could range from watery expanses to rugged, rocky shores. And if you looked up, you might see its sibling planets hanging in the sky, some appearing larger than our moon, a constant reminder you're part of an intricately packed system. But here's where it gets even more intriguing. TRAPPIST-1e's tight orbit means it's likely tidally locked, with one side forever facing the star and the other locked in darkness. Yet, unlike harsher tidally locked worlds, this planet might benefit from its dense atmosphere, if it has one, to distribute heat, creating a twilight zone where temperatures could be just right for liquid water. There's also the possibility of geothermal activity heating the subsurface, offering pockets of warmth even on the frigid night side, the real kicker. This entire system is only 39 light-years away, making it one of the best targets for future study. With telescopes like the James Webb Space Telescope, we're already peering into its atmosphere, hunting for traces of water vapor, oxygen, or even methane chemical signatures that could hint at life. TRAPPIST-1e isn't just a scientific curiosity. It's a test case for how common or rare Earth-like worlds might be in the cosmos. And with every new observation, we're inching closer to answering whether this watery, rocky jewel could be a second home for life among the stars. LHS 1140b isn't just another exoplanet. It's a heavyweight contender in the search for life, a super-Earth with twice our planet's mass and a makeup that suggests it could be more than just a barren rock. What sets this world apart is its thick, potentially life-sustaining atmosphere, a blanket of gases that might cling tightly to its surface, shielding it from the harshness of space. Orbiting a quiet, cool red dwarf star 49 light-years away, this planet sits perfectly in the habitable zone where temperatures could allow water to flow freely. Unlike many red dwarf systems where stars bombard their planets with deadly radiation, LHS 1140b's host star is unusually calm, offering a rare stability that might have preserved its atmosphere and any oceans for billions of years. Picture standing on this distant world, the sky a deep, hazy orange, the air thick enough to scatter the dim red light of its sun into perpetual twilight. The landscape could be a rugged mix of rocky plains and deep valleys, with rivers carving through the terrain, fed by melting ice or hidden aquifers. Artist renditions often show LHS 1140b as a world of contrast, towering cliffs shrouded in mist, vast shallow seas reflecting the dull glow of its star, and skies streaked with unfamiliar cloud patterns. The gravity here would feel heavier than Earth's, pressing down with twice the force, but if life exists, it might have adapted to thrive under these conditions, clinging to coastlines or thriving in subsurface caves where water and warmth persist. The real magic lies in its star's temperament. Red dwarfs are notorious for their violent flares, capable of stripping away atmospheres over time. But LHS 1140 is different, older, quieter, and kinder to its planetary companion. This stability means that if water ever formed here, it might still be there today, pooled in crater lakes or hidden beneath ice sheets. Scientists are particularly excited about this planet because its thick atmosphere, if confirmed, could act like a planetary pressure cooker, trapping heat efficiently and maintaining surface temperatures hospitable to liquid water. Even more tantalizing is the possibility that its skies contain gases like nitrogen or carbon dioxide ingredients that could hint at geological activity or even biological processes. Future telescopes will play a crucial role in unraveling this world's secrets. By analyzing the starlight filtering through its atmosphere, we might detect signs of water vapor or oxygen, molecules that would turn LHS 1140b from a promising candidate into a frontrunner in the hunt for alien life. For now, it remains a mesmerizing what-if, a super-Earth with all the right pieces in place, waiting patiently 49 light-years away for us to uncover its story. Among the countless exoplanets discovered, Kepler 442b stands out as one of the most Earth-like worlds we've ever found. A rocky planet with an Earth Similarity Index score of 0.84, putting it neck and neck with our own world in terms of potential habitability. To put that into perspective, the ESI scale runs from 0 to 1, with Earth scoring a perfect 1, and anything above 0.8 considered remarkably Earth-like. Kepler 442b isn't just close, it's practically flirting with the upper limits of what's possible. Orbiting a quiet orange dwarf star over 1,200 light-years away, this world basks in a gentle, steady light, receiving about 70% of the solar energy Earth gets from our Sun, enough to keep water liquid without scorching its surface. Unlike the turbulent red dwarfs that plague many exoplanets with deadly radiation flares, Kepler 442b star is calmer and more stable, offering a far gentler environment for potential life to take root. The planet's orbit is another stroke of cosmic luck, a near-perfect 267-day year that places it squarely in the habitable zone, with minimal eccentricity, meaning its path around its star is almost circular, avoiding extreme temperature swings. On Earth, our slightly elliptical orbit brings seasonal variations, but Kepler 442b's steadier journey could mean a more consistent climate, free from the punishing winters or scorching summers that might destabilize emerging ecosystems. Then there's the matter of size and composition. Kepler 442b is roughly 1/3 larger than Earth, likely giving it a stronger gravitational pull, but still well within the range where rocky terrain and liquid water could exist. Crucially, its density suggests a metal-rich core and a silicate mantle, key ingredients for the geologic activity that drives Earth's carbon cycle, regulating atmospheres and climates over millennia. If this planet has active volcanoes or tectonic plates, those processes could recycle nutrients and stabilize temperatures, creating the long-term conditions life needs to evolve. But what truly sparks the imagination is the light. Kepler 442b's orange sun would paint its skies in perpetual gold and amber, casting long shadows across landscapes that might resemble Earth's own, rolling hills, deep valleys, or even vast, tranquil oceans. Photosynthetic life here, if it exists, could evolve to harness those specific wavelengths, turning the planet's surface into a tapestry of deep purples and blacks, colors better suited to absorb its star's cooler light. The real challenge lies in confirming what we can't yet see. Current telescopes struggle to analyze Kepler 442b's atmosphere directly, but future instruments could detect the chemical fingerprints of water, oxygen, or even industrial pollutants, hints that something more than geology is at work. For now, this distant world remains a tantalizing mystery, a near-Earth clone waiting patiently in the cosmos, reminding us that the ingredients for life might be far more common than we ever dared to hope. Teegardens Star B is a hidden gem among potentially habitable worlds, orbiting one of the smallest and coolest stars ever discovered. A dim red dwarf so faint it wasn't even spotted until 1999. This planet, just 12 light-years away, is a testament to how much we still have to learn about our cosmic neighborhood. Its star emits less than 1,000th of the Sun's visible light, casting a perpetual twilight over the planet. Yet despite this gloom, Teegardens Star B might be one of the most promising candidates for liquid water, and perhaps life in the entire galaxy. What makes this world so fascinating is its balance of extremes. It orbits its star in a mere 4.9 Earth days, a blisteringly short year by our standards, but because the star is so cool, the planet still sits comfortably in the habitable zone. Surface temperatures could hover around 28 degrees Fahrenheit cold, but not impossible for liquid water if the planet has a dense atmosphere or geothermal hotspots. Unlike many red dwarf planets blasted by radiation, Teegardens Star is remarkably stable with few flares, offering a gentler environment where an atmosphere could persist over billions of years. Picture a landscape where the sun never rises higher than a dull, red ember on the horizon, casting long shadows across valleys that might cradle ice-covered lakes or sluggish rivers fed by underground springs. The real challenge lies in uncovering its secrets. Teegarden star B doesn't transit, meaning it doesn't pass in front of its star from our vantage point, ruling out the usual method of studying atmospheres. Instead, scientists had to detect it through the subtle wobble of its star, a technique that reveals little about its actual conditions. Future telescopes might analyze reflected starlight to hunt for water vapor or oxygen, but for now, the planet remains a tantalizing enigma. If life exists here, it would likely cling to niche environments, deep ocean vents, subterranean caves, or those narrow bands between eternal frost and faint warmth. Yet the possibility alone is electrifying. A stable, ancient world this close to Earth could be a prime target for future interstellar probes. Imagine a civilization thriving under a star so dim it's invisible to our naked eyes, hidden in plain sight just 12 light-years away. Teegarden's star B doesn't just expand our list of habitable worlds, it forces us to rethink what habitable even means. K2-18b shatters our expectations of what a habitable world might look like, because this isn't just another rocky planet like Earth. Imagine a world swaddled in a thick hydrogen blanket, an atmosphere so dense it creates crushing pressures at the surface, yet somehow, against all odds, it harbors a secret that's electrified astronomers: water vapor. Recent observations revealed unmistakable signs of this life, giving molecules swirling in its skies, making K2-18b the first exoplanet of its kind where we've directly detected water in the atmosphere. But here's the twist: this planet defies categorization. At 8.6 times Earth's mass, it's either a super-Earth or a mini-Neptune, a gaseous world with no true surface, where the very air might gradually compress into a liquid ocean beneath the clouds. The term Hycean was coined just for planets like this, hypothetical worlds with hydrogen atmospheres covering vast, scorching hot or ice-locked oceans. Picture an endless twilight sea beneath a hazy orange sky, where the water isn't confined to familiar lakes or rivers but exists as a global layer, hundreds of miles deep, crushed under an atmosphere 10 times thicker than Earth. If you could descend through K2-18b's swirling clouds, you'd encounter a realm where the boundary between air and liquid blurs, a place where the pressure turns hydrogen into a strange metallic fluid, and where temperatures could reach hundreds of degrees near the ocean's surface. It sounds inhospitable, but life, if it exists here, wouldn't play by Earth's rules. The discovery of water vapor raises tantalizing questions. On Earth, water is a canvas for life, but on K2-18b, it might mix with organic molecules in the upper atmosphere, creating a chemical soup energized by the faint glow of its red dwarf star. Some scientists speculate that microbial life could float in those high-altitude layers, far above the crushing depths, harvesting energy from atmospheric reactions. Others propose that tidal, heating the gravitational squeeze from its close orbit, might keep subsurface oceans liquid beneath miles of ice, hidden from the raw hostility above. What makes K2-18b so revolutionary isn't just its water. It's what it represents. For decades, we've fixated on finding Earth twins, but this planet proves habitable conditions might arise in utterly alien environments. Its star, though dim, is quieter than most red dwarfs, giving any potential life forms a fighting chance against radiation. And at 110 light-years away, it's close enough for the James Webb Space Telescope to probe its atmosphere for more clues. Not just water, but perhaps methane or even dimethyl sulfide, a molecule only produced by life on Earth. K2-18b forces us to broaden our imagination. A habitable zone isn't just about temperature, it's about chemistry, stability, and the sheer tenacity of life to adapt. This planet might not have mountains or shorelines, but it could harbor something even more extraordinary, proof that the universe builds oases in the unlikeliest of places. GJ357d defies easy classification, a planet caught between two identities, each more intriguing than the last. Discovered just 31 light-years away, this enigmatic world weighs in at 6.1 times Earth's mass, placing it firmly in the super-Earth category. But here's where things get messy. Is it a scaled-up version of our own rocky planet, or a scaled-down Neptune, cloaked in a thick gaseous envelope? The answer could redefine what we consider habitable. What's undeniable is its prime real estate. GJ357d orbits a quiet red dwarf star in the habitable zone, where temperatures might allow liquid water to exist if the planet has the right atmosphere. Picture a world where the sun hangs small and dim in the sky, casting a feeble glow over landscapes that could range from frozen tundras to steam-shrouded volcanoes. The catch: its orbit lasts 55 Earth days, meaning seasons, if they exist at all, would drag on for months under that perpetual reddish twilight. The debate over its nature splits scientists down the middle. Some models suggest GJ357d is a rocky behemoth, its immense gravity compressing a dense iron core and silicate mantle, possibly even hosting active plate tectonics. If so, it could have continents, mountain ranges, and deep basins where water collects, assuming it hasn't all frozen or evaporated. Others argue it's a mini Neptune, wrapped in a hydrogen-helium atmosphere so thick that the surface, if there is one, lies buried under crushing pressures and scalding temperatures, with any oceans existing not as liquid water but as exotic supercritical fluids. Yet even the mini Neptune scenario sparks curiosity. Certain theories propose that beneath those oppressive gas layers, a rocky core might cradle oceans kept liquid by internal heat or tidal forces. Life here wouldn't resemble Earth's surface dwellers. It might cling to hydrothermal vents in abyssal darkness, or float in high-altitude layers where temperatures and pressures are milder. The star itself adds another layer of intrigue. Unlike the turbulent red dwarfs that plague many exoplanets, GJ357 is relatively calm, offering a stable environment where an atmosphere could persist for billions of years. That stability raises the stakes. If this planet is rocky and has clung to its air, it could be one of the oldest potentially habitable worlds we've ever found, a time capsule from the early universe. Future telescopes might settle the debate by analyzing the chemistry of its atmosphere, hunting for traces of water, carbon dioxide, or even methane. For now, GJ357d stands as a reminder that habitability isn't a binary concept. A planet doesn't need to mirror Earth to cradle life. It just needs to carve out its own version of survival. Whether this world is a steamy super-Earth or a shrouded mini-Neptune, it challenges us to expand our imagination about where life might take root in the cosmos. Kepler-62f feels like a glimpse into Earth's distant future, a world orbiting a star much older than our Sun, a silent witness to billions of years of cosmic history. This exoplanet, 1,200 light-years away, circles a dim orange dwarf that's already halfway through its lifespan, burning steadily with the patience of a star that's in no rush to die. What makes Kepler-62f so compelling isn't just its age, but its position. Perched at the outer edge of its star's habitable zone, where the light is faint but just enough to keep water liquid. Imagine a place where the sun hangs small and pale in the sky, casting weak golden rays over landscapes that might resemble Earth's Arctic tundras or mist-covered fjords. The planet's orbit is a study in extremes. A single year here lasts 267 Earth days, not drastically longer than ours, but that extra time matters when you're soaking up only 20% of the sunlight Earth receives. Seasons, if they exist at all, would stretch out in slow motion, with winters lingering for months under skies streaked with unfamiliar constellations. Yet this distance from its star might actually work in its favor. While closer planets could be scorched by flares or tidal locking, Kepler-62f's wide berth grants it stability. Its rotation could be free from the grip of tidal forces, allowing for day-night cycles like ours, critical for distributing heat and maintaining a balanced climate. Then there's the question of water. Models suggest Kepler-62f could be a water world, its surface almost entirely covered by a global ocean. With such vast liquid reserves, tides might surge under the pull of neighboring planets, stirring nutrients and energy through its depths. Or perhaps its more varied continents peeking through the waves, their shorelines etched by slow, rhythmic tides. The real mystery lies in its atmosphere. A thick blanket of greenhouse gases like carbon dioxide could trap just enough heat to offset its star's weakness, turning what might seem like a frozen wasteland into a world of liquid seas and hazy, temperate skies. What truly captivates scientists is this planet's potential for longevity. Older stars often mean older planets, and Kepler-62f's system has had twice as much time as Earth's for life to emerge and evolve. If life exists here, it's had billions of extra years to adapt, to experiment, to diversify in ways we can barely fathom. Picture organisms that thrive in perpetual twilight, their metabolism slowed to match the star's languid rhythm, or ecosystems built around geothermal vents in the absence of strong sunlight. Kepler-62f challenges our assumptions about habitability. It proves that life, if it's tenacious enough, doesn't need a young, vibrant star, just the right conditions and time. Lots and lots of time. As we peer deeper into the cosmos, worlds like this remind us that the story of life might be far older and far more patient than we ever imagined. Wolf 1061c isn't just another exoplanet, it's a study in cosmic extremes, a world where the skies themselves might rage with storms unlike anything we know. Orbiting a quiet red dwarf just 14 light-years away, this planet is one of our closest potentially habitable neighbors, but habitable here comes with an asterisk. Wolf 1061c hugs its star so tightly that a full year lasts a mere 18 Earth days, placing it right on the inner edge of the habitable zone. That proximity means the planet is likely tidally locked, with one face forever scorched by the dim red glow of its sun, and the other plunged into eternal icy darkness. But between these two extremes lies a narrow band of twilight, a liminal space where temperatures might balance just right for liquid water to pool, if the planet can cling to an atmosphere thick enough to distribute heat. What makes this world so fascinating isn't just its precarious position, it's the weather. Models suggest Wolf 1061c could be a planet of howling winds, where atmospheric currents race to redistribute heat from the blazing dayside to the frozen nightside. Picture cyclones larger than continents, swirling across the Terminator line in endless tempests, or torrential rains that evaporate before they ever hit the ground. And if the planet has oceans, those winds could whip up waves hundreds of feet tall, driven by temperature differences more extreme than anything on Earth. The sheer violence of these systems raises a provocative question. Could life survive in such chaos? Microbes on Earth thrive in boiling vents and acidic pools, so perhaps organisms here could anchor themselves in deep ocean trenches or beneath icy crusts, shielded from the fury above. Then there's the broader context. Wolf 1061c isn't alone. It's part of a compact three-planet system, with two siblings sharing its orbit: Wolf 1061b, a scorching rocky world too close to the star, and Wolf 1061d, a colder outlier that might be a gas dwarf. This trio's gravitational dance could be key to Wolf 1061c's habitability. Some scientists speculate that tidal forces from its neighbors might generate internal heat, keeping subsurface oceans liquid even without stellar warmth. Others warn that these interactions could destabilize orbits over time, triggering climatic shifts that would make Earth's ice ages look mild. The star itself adds another layer of intrigue. While many red dwarfs flare violently, Wolf 1061 is relatively stable, a rare calm spot in a stormy stellar class. That stability gives any atmosphere a fighting chance to endure, raising the tantalizing possibility that this world, for all its extremes, might have held onto its air and water for billions of years. Future telescopes could analyze the light filtering through its atmosphere, hunting for signs of water vapor or even oxygen, hints that something stirs beneath those turbulent skies. Wolf 1061c forces us to confront the adaptability of life. It's a world where the rules aren't just different, they're rewritten daily by winds and tides we can barely imagine. Yet in that chaos, there might be pockets of calm, places where life could carve out a stubborn existence. As we study this turbulent neighbor, we're reminded that habitability isn't about perfection, it's about persistence. Kepler 452b isn't just another exoplanet, it's a cosmic mirror held up to Earth, reflecting what our own world might become in another billion years. Orbiting a sun-like G-type star 1,400 light-years away, this planet is often called Earth's older cousin, and for good reason. Its star, Kepler 452, is nearly identical to ours but older around 6 billion years compared to the Sun's 4.6 billion, giving this system a head start in the grand timeline of cosmic evolution. The parallels don't stop there. Kepler 452b completes an orbit in 385 days, just 20 days longer than Earth's year, and sits squarely in its star's habitable zone where liquid water could pool on its surface. If you stood on this planet, the sun in the sky would look almost indistinguishable from our own, a familiar yellow disk casting warm light over landscapes that might feel eerily recognizable. But this isn't a twin, it's a glimpse into Earth's possible future. Kepler 452b is about 60% larger than our planet, placing it in the super-Earth category with gravity roughly twice as strong. Picture towering mountain ranges worn down by eons of erosion, or vast, shallow seas where the pull of tides is far more intense. Its star, though similar to ours, has grown slightly brighter with age, meaning this planet receives about 10% more energy than Earth does today, a preview of what our own world might experience as the sun gradually heats up over the next billion years. The implications are staggering. If Kepler 452b once had oceans like ours, they could now be slowly evaporating under that intensified glow, leaving behind sprawling salt flats or steam-shrouded jungles struggling to adapt. The real intrigue lies in its longevity. A planet this old has had ample time for life to emerge and evolve far longer than Earth's own biological timeline. If life exists here, it might have weathered cosmic calamities we can scarcely imagine, adapting to creeping changes in climate or radiation over epochs. Scientists speculate that microbial life could have arisen in Kepler 452b's distant past, only to retreat underground as surface conditions grew harsher, or perhaps even evolve into complex forms uniquely suited to this older, slightly hotter world. The planet's larger size also suggests more geologic activity. Think stronger volcanic outgassing replenishing its atmosphere, or more vigorous plate tectonics recycling nutrients across its surface. Yet for all its promise, Kepler 452b comes with unanswered questions. We still don't know if it has a thick atmosphere to buffer its star's growing heat, or whether its oceans, if they ever existed, have boiled away entirely. Future telescopes might detect chemical signatures in its air, like carbon dioxide or water vapor, that reveal its true nature. For now, this world stands as a hauntingly familiar yet alien reminder. Earth won't always be the haven it is today. Studying Kepler 452b isn't just about finding life elsewhere, it's about understanding our own planet's distant future, written in the skies of another world. Ross 128b offers something rare in the cosmic hunt for habitable worlds: a peaceful home. While many exoplanets orbit temperamental red dwarfs prone to violent flares, this planet circles one of the quietest stars ever discovered, a serene red dwarf just 11 light-years away. Ross 128, its host star, emits barely any radiation bursts, making it a cosmic oasis where an atmosphere and any potential life could thrive without the constant threat of sterilization. Add to that the planet's Earth-like mass, roughly 1.3 times our own, and you've got a recipe for one of the most promising candidates for habitability in our stellar neighborhood. What makes Ross 128b truly special isn't just its calm star or familiar size, it's the Goldilocks positioning. Nestled snugly in its star's habitable zone, this world receives only 38% more stellar energy than Earth, placing it in a range where liquid water could exist with the right atmospheric conditions. But here's the twist. Unlike most red dwarf planets tidally locked into eternal day and night sides, Ross 128b might actually rotate thanks to its star's unusually relaxed gravitational grip. That means it could experience day-night cycles like Earth's, distributing heat more evenly and potentially fostering stable climates, a rarity in red dwarf systems. Then there's the tantalizing possibility of an atmosphere. While we can't yet peer directly at its skies, astronomers are itching to study the chemical fingerprints of its air with next-generation telescopes. A thick atmosphere could trap enough heat to compensate for the star's faint glow, creating temperate zones where water lingers in liquid form. But even if its air is thin or long lost, the planet's geology might still hold secrets. Subsurface oceans, warmed by radioactive decay or tidal forces, could persist beneath frozen crusts, offering refuge for extremophiles in a hidden aquatic realm. The star itself holds clues to the planet's past and future. Ross 128 is drifting toward us, set to become Earth's closest stellar neighbor in just 71,000 years. That cosmic commute makes it a prime target not just for observation, but for ambitious projects like Breakthrough Starshot, which envisions sending probes to nearby exoplanets. Imagine a day when we could glimpse this world's ruddy landscapes, its alien skies streaked with unfamiliar cloud patterns, or better yet, detect the faint glow of artificial lights hinting at civilizations that found refuge under this gentle star. For now, Ross 128b remains a quiet enigma, a world balancing on the edge of discovery. Its serenity is its greatest strength, a rare stability in a universe of chaos, offering a glimpse of what life might look like when the stars themselves play nice. In the hunt for habitable worlds, this planet isn't just a candidate, it's a beacon of possibility. HD 40307G doesn't just orbit within its star's habitable zone, it practically redefines it. This intriguing world, located 42 light-years away, has earned a rare label among exoplanets, superhabitable. What does that mean? Imagine a planet where everything, size, atmosphere, and even geology aligns to create conditions that might surpass Earth's own suitability for life. HD 40307G is a heavyweight in this category, a super-Earth 6 times more massive than our planet, with a thick, insulating atmosphere that could act like a planetary snug blanket, trapping heat so efficiently that even its dim orange star can't plunge it into eternal frost. The magic lies in its star's gentle glow. Unlike the volatile red dwarfs that dominate habitable zone discoveries, HD 40307 is a K-type orange dwarf, older, calmer, and more stable. It emits less harmful ultraviolet radiation than our Sun, but here's the twist: the planet's hefty atmosphere could compensate for that faintness. A dense mix of carbon dioxide and nitrogen might create a greenhouse effect powerful enough to keep surface temperatures balmy, even as far out as it orbits. Picture a world where the air presses down with twice Earth's surface pressure, scattering sunlight into perpetual golden hour hues, with skies streaked by high-altitude ice clouds reflecting the weak glow of its star. Then there's the question of water. With such efficient heat retention, HD 40307G could maintain vast, shallow seas, their surfaces rippling under slow, heavy waves. Or perhaps it's a world of sprawling wetlands where rivers carve through valleys fed by constant drizzle, a planet caught in a never-ending temperate drizzle. The sheer variety of possible landscapes boggles the mind, from mist-covered highlands to low-lying basins where the dense air muffles sound, creating an eerie quiet broken only by distant storms. But the real kicker, this planet might rotate. Many superhabitable candidates are tidally locked, but HD 40,307G's wide orbit suggests it could experience day-night cycles like Earth's, distributing warmth more evenly and preventing the brutal extremes seen on other worlds. Seasons here, if they exist, would be subtle long, languid shifts in temperature as the planet tilts under its ancient sun. The term superhabitable isn't just about comfort, it's about time. HD 40,307G star is billions of years older than our Sun, meaning this planet has had far longer for life to emerge, evolve, and diversify. If biology took root here, it's had epochs to perfect itself, perhaps filling every niche with organisms we can't begin to imagine. Future telescopes could hunt for biosignatures in its atmosphere, but for now, HD 40,307G stands as a humbling thought experiment. What if Earth isn't the pinnacle of habitability? What if, out there, worlds exist that are even kinder to life? This planet challenges us to reconsider our cosmic insignificance and wonder if, somewhere under those golden skies, nature has already crafted a better version of home. Kepler 1649c was hiding in plain sight. Buried in old Kepler Space Telescope data, this Earth-sized world eluded detection until a second look revealed its presence, proof that even our most advanced tools can overlook gems in the cosmic haystack. What makes this planet extraordinary isn't just its late discovery, but its uncanny resemblance to Earth. Clocking in at just 1.06 times Earth's radius, it's one of the closest matches we've found in terms of size, suggesting a rocky composition with familiar landscapes, mountains, valleys, perhaps even oceans shimmering under an alien sun. But that sun is nothing like ours. Kepler 1649c orbits a dim red dwarf, a star so small and faint it would appear as little more than a glowing ember in its sky. Yet despite this stellar modesty, the planet sits squarely in the habitable zone, basking in just enough warmth to allow liquid water to pool on its surface if the other pieces fall into place. The star's feeble glow means Kepler 1649c hugs close, completing a full orbit in only 19.5 Earth days. Such proximity usually spells doom for red dwarf planets, leaving them vulnerable to tidal locking or brutal stellar flares. But here's the twist. Initial observations suggest this star is unusually calm. Unlike the tempestuous red dwarfs that blast their planets with radiation, Kepler 1649 host might offer a gentler environment, giving any potential atmosphere and life a fighting chance. Then there's the light itself. Photosynthetic organisms on Earth thrive under our sun's white-yellow rays, but on Kepler 1649c, the dominant wavelengths would be deep red and infrared. Plant analogues here, if they exist, might evolve to absorb these longer wavelengths, turning entire landscape shades of black or purple to soak up every precious photon. The perpetual crimson hue could also affect weather patterns, with atmospheric gases scattering light differently than on Earth, creating sunsets that paint the sky in surreal, monochrome palettes. The real intrigue lies in what we don't yet know. Kepler 1649c doesn't transit its star from our vantage point, making atmospheric studies a challenge. Future telescopes might analyze reflected light for hints of water or oxygen, but for now, this world remains a tantalizing silhouette, a nearly Earth-sized mystery 300 light-years away. Its discovery reminds us that the cosmos still holds surprises, even in data we thought we'd exhausted. Every overlooked signal could be a world like this, waiting to rewrite the story of life among the stars. TOI 700d is a quiet revolution in exoplanet science, not because it's the most Earth-like world we've found, but because of how it was discovered. This planet, orbiting a small, cool red dwarf 100 light-years away, was spotted by NASA TESS mission, a telescope designed to hunt for worlds crossing in front of their stars. But TOI 700d didn't just cross its star, it corrected us. Initially, astronomers mistook its host star for a more active, Sun-like star, which would have placed the planet outside the habitable zone. It took sharp-eyed researchers and a bit of algorithmic luck to realize their error, revealing TOI 700d as one of the first Earth-sized planets in the habitable zone ever detected by TESS. That moment of scientific humility reshaped our understanding of the system, proving even well-studied data can hide paradigm-shifting secrets. What makes this world so compelling is its delicate balance. Like many red dwarf planets, TOI 700d is almost certainly tidally locked, with one face forever bathed in the dim ruby light of its star and the other cloaked in endless night. But unlike some of its cousins, this planet might just skirt the extremes. Climate models suggest its atmosphere, if it has one, could distribute heat efficiently, preventing the day side from boiling into a desert or the night side from freezing into a wasteland. Instead, simulations paint a picture of a world where thick clouds blanket the star-facing hemisphere, reflecting just enough light to keep temperatures mild, while ocean currents, if present, ferry warmth to the dark side. Imagine standing on the Terminator line, where the sun forever hangs on the horizon, casting long shadows over a landscape of rolling fog banks and sluggish, tide-lapped shores. Those same simulations reveal tantalizing possibilities. Some predict TOI 700d as a water world, its surface entirely covered by a global ocean with no land in sight. Others suggest a more Earth-like mix of seas and continents, where rain might fall in slow, perpetual cycles under a sky streaked with high-altitude ice clouds. The most optimistic models even hint at an atmosphere rich in carbon dioxide, a greenhouse gas that could trap enough heat to offset the star's faint glow, creating habitable pockets across the planet. But here's the catch: we don't yet know if TOI 700d has any atmosphere. Red dwarfs are notorious for stripping away planetary air with their fierce youth, and while TOI 700 is now quiet, its past might have been stormier. The real hope lies in future observations. TOI 700d's star is small and dim enough that next-generation telescopes could analyze its atmosphere by studying the starlight filtering through it. A detection of water vapor or oxygen would catapult this world to the top of the habitable list, but even the absence of those gases could teach us something profound about how atmospheres survive or fail under red dwarf suns. What makes TOI 700d special isn't just its potential for oceans or clouds. It's the reminder that discovery isn't a straight line. A misclassified star, a second look at the data, and suddenly a whole new world emerges from the noise, one that challenges our assumptions about where life could cling and how we might find it. GJ 667cc turns the concept of a habitable world upside down literally. This planet doesn't just orbit one star, it's part of a tangled cosmic dance with three, a stellar trio where the sunsets could paint the sky in surreal, shifting hues. At 23 light-years away, it's one of our closest potentially habitable neighbors, but habitable here comes with asterisks the size of supernovas. The primary star, GJ 667c, is a dim red dwarf, while its two companions, orange dwarfs, circle farther out, casting faint secondary glows that might barely pierce the planet's thick, hazy atmosphere. Standing on GJ 667cc's surface, you'd witness a sun that appears 3 times larger than ours, hanging like a dull red orb in a sky streaked with the distant, glimmering diamonds of its stellar siblings. What makes this world truly bizarre isn't just its 3 suns, it's the heavy elements saturating its makeup. Most red dwarf systems are metal-poor, but J667c is swimming in iron, magnesium, and silicon, elements typically forged in the hearts of massive, ancient stars. This cosmic treasure trove suggests the planet itself could be denser than Earth, with a gravity 20% stronger, pulling everything from ocean tides to mountain ranges into sharper relief. Imagine walking across landscapes where the air feels thicker, where rain falls slower and heavier, and where even the simplest movements demand more effort under that relentless gravitational tug. Then there's the climate, tucked snugly in the habitable zone. J667c receives 90% of the stellar energy Earth gets from our Sun, but nearly all of it arrives as infrared radiation, invisible to human eyes. Photosynthetic life here, if it exists, might evolve to harness these longer wavelengths, turning entire ecosystems shades of deep violet or black to absorb every scrap of energy. The planet's thick atmosphere could trap that heat efficiently, but with 3 stars tugging at its orbit, seasonal shifts might be wild and unpredictable. One model suggests the combined gravitational pull could stretch and compress the planet's path over millennia, triggering climatic swings between ice ages and greenhouse extremes. Yet amid this chaos, J667c holds one critical advantage: time. Its star system is ancient, possibly twice as old as our Sun, granting any potential life an unimaginable head start. Picture organisms that have weathered eons of stellar flares, gravitational tides, and atmospheric upheavals. Life not just adapted to instability, but thriving on it. Future telescopes might detect biosignatures in its air, but for now, this planet stands as a testament to nature's creativity. In a universe where single-star systems seem mundane, J667c dares to ask, what happens when life gets not one sun but 3? Kepler 1229b presents a paradox, a world of extremes where fire and ice might coexist under the faint glow of a red dwarf star. Nestled within the constellation Cygnus, this exoplanet orbits its dim sun every 86 Earth days, tracing a path so elliptical that its distance from the star varies dramatically. Picture this: at its closest approach, Kepler 1229b basks in a surge of warmth, only to swing outward into the frigid depths of space months later. This isn't just a quirky orbit, it's a gravitational roller coaster that could turn the planet's interior into a geothermal wonderland. The star itself is a textbook red dwarf, small, cool, and prone to violent flares in its youth. But Kepler 1229b's saving grace might be age. Its system is ancient, giving the star time to settle into a quieter rhythm, sparing the planet the worst of its radiation outbursts. That stability raises a tantalizing possibility. If this world has an atmosphere, it could have clung to it for billions of years, shielding any surface water from evaporating into space. Yet the real intrigue lies beneath the surface. The planet's eccentric orbit subjects it to intense tidal forces, flexing its crust like putty with each stellar close encounter. That constant kneading could generate enough internal heat to sustain vast subsurface oceans, hidden beneath miles of ice. Imagine a world where the surface is frozen solid, but dig deep enough, and you'd find caverns of liquid water warmed by the planet's own restless core. On Earth, life thrives in similar extremes around hydrothermal vents at the bottom of the ocean, where sunlight never reaches. Kepler 1229b's oceans, if they exist, could be even more expansive, forming a global aquifer sandwiched between ice above and rock below. The pressure at those depths would be crushing, but extremophiles don't care about comfort. Microbes here might feed on chemical reactions between water and minerals, or harness geothermal energy bubbling up from below. The kicker: this planet's host star emits mostly infrared light, meaning any photosynthesizing organisms would need to adapt to wavelengths invisible to our eyes. Picture ecosystems bathed in perpetual twilight, where the dominant life forms are shades of black or deep purple, evolving to soak up every scrap of energy from their feeble sun. Or perhaps life here has abandoned light entirely, relying on chemosynthesis in the dark, warm embrace of subsurface seas. Kepler 1229b challenges our definitions of habitability. It's a world where liquid water might not glisten on the surface but slosh in secret, where the real action happens far below the ice. Future telescopes could hunt for indirect clues detecting trace gases in its atmosphere that hint at geological activity, or measuring heat radiating from its crust. For now, this enigmatic planet reminds us that life, if it's stubborn enough, doesn't need a sunny beach. Sometimes all it needs is a little warmth from within. LP 899c didn't just join the list of potentially habitable exoplanets, it shot straight to the top tier, earning the title of second most Earth-like world we've ever discovered. Confirmed in September 2022 by the Speculus telescopes, this planet is a game-changer, not just for its potential to host life, but for what it reveals about our search strategies. Orbiting a tiny, ultra-cool red dwarf star 100 light-years away, LP 899c is a masterclass in cosmic serendipity. Initially flagged by NASA, a test mission as a candidate, it took the precision of ground-based observatories to unveil its true significance. A rocky world 40% larger than Earth, perched perfectly in its star's habitable zone. What sets this planet apart isn't just its size or position, it's the light. Unlike the harsh environments of many red dwarf systems, LP 899 is a gentle parent star emitting minimal flares and radiation. That stability matters while its sibling planet, LP 899b, orbits too close for comfort. This world sits farther out, completing a year in just over 8 Earth days, short by our standards, but ideal for a star this faint. The result, surface temperatures that could hover near Earth-like ranges, assuming it has an atmosphere to trap heat. And here's the kicker. Models suggest LP 899c might be a better candidate for holding onto its atmosphere than many of its peers. Its larger size means stronger gravity, which could help it cling to protective gases even over billions of years. Now picture standing on this world. The sky looms dark, streaked with the deep crimson glow of a star so small it appears no larger than a distant campfire. Days and nights blur together under tidal locking, but the terminator line, the border between eternal light and endless dark, might host a ribbon of temperate conditions. Rivers could carve through valleys here, fed by meltwater from icy highlands on the night side, while geothermal vents bubble beneath thick ice sheets, offering oases of warmth. The real excitement lies in what's next. LP 899c is prime real estate for the James Webb Space Telescope. With its star so dim, JWST can analyze atmospheric components with unprecedented clarity, hunting for traces of water vapor, carbon dioxide, or even methane gases that could hint at geological activity or just maybe biological processes. But the stakes are higher than one planet. This system is a testing ground for theories about red dwarf habitability. If LP 899c has a robust atmosphere despite its star's weak warmth, it could rewrite the rules for where we search for life. Ultimately, LP 899c isn't just another exoplanet. It's a beacon of possibility, a world that challenges our assumptions about where life could cling and how common it might truly be. As telescopes grow sharper, this distant planet could become the Rosetta Stone for decoding the secrets of habitable worlds beyond our solar system. Kepler 283c sits in a cosmic tightrope act, a world where the very forces that could make it habitable might also tear it apart. This exoplanet, discovered in 2014, orbits a star smaller and cooler than our Sun, tucked into a compact system where the planets huddle close like siblings around a campfire. With a year lasting just 93 Earth days, Kepler-283c hugs its star at a distance that would vaporize worlds in our solar system. But here, the star's faint glow means the planet basks in just enough warmth to flirt with the idea of liquid water. Yet what truly sets this world apart isn't just its position, it's the tectonic drama that might be unfolding beneath its surface. The planet's proximity to its star subjects it to relentless tidal forces, stretching and compressing its crust with every orbit. On Earth, such gravitational kneading powers the volcanic fires of Io, Jupiter's hyperactive moon. Kepler-283c could be experiencing something similar, a world racked by ceaseless eruptions where magma bubbles up through fissures and ash plumes blot out its crimson skies. Picture a landscape of jagged basalt plains, their surfaces cracked and reformed by lava flows, or vast calderas spewing sulfurous gases into an already thick atmosphere. But here's the twist: this volcanic chaos might be the key to life. On our own planet, volcanoes played a crucial role in shaping the early atmosphere, belching out carbon dioxide and water vapor that stabilized temperatures and filled ancient oceans. If Kepler-283c's eruptions are frequent but not apocalyptic, they could be recycling essential gases, maintaining a climate where liquid water and perhaps life could persist. Then there's the star itself, a quiet elder in cosmic terms. Kepler-283 is roughly half the Sun's age, but in red dwarf years, that's ancient. Most stars of this type spend their youth unleashing deadly radiation storms, but by now, this one has settled into a calm middle age, offering a stable environment for its planets. That longevity is a double-edged sword. On one hand, it means Kepler-283c has had billions of years for its geology and any potential biology to evolve. On the other, the planet's tidal heating might have slowly baked away its water, leaving behind a desiccated husk. The critical factor could be its atmosphere. A thick blanket of gases like carbon dioxide could trap volcanic outgassing, creating a pressure cooker effect that keeps water liquid even as the star's feeble light struggles to warm the surface. The compactness of the system adds another layer of intrigue. Kepler-283c shares its space with at least one sibling planet, Kepler-283b, a scorching world orbiting even closer to the star. Their gravitational dance might be stirring the pot further, adding tidal flexing that pumps more heat into Kepler-283c's interior. It's a delicate balance: too much heating, and the planet's oceans boil away; too little, and it freezes solid. But if the equilibrium is just right, this could be a world where volcanic islands dot global seas, their shorelines warmed by hydrothermal vents that teem with exotic life forms adapted to the planet's fiery rhythms. Future telescopes might one day detect the chemical fingerprints of Kepler-283c's volcanic activity, sulfur compounds or carbon monoxide leaking into its atmosphere. For now, it remains a testament to the universe's creativity, a planet where destruction and creation are locked in an endless dance, and where the very forces that threaten to rend it apart might also be the ones that make it alive. GJ1061c is a cosmic tightrope walker, a world balancing on the edge of habitability in a system so compact its entire planetary family could fit inside Mercury's orbit. Discovered just 12 light-years away, this exoplanet stands out not for flashy extremes, but for its quiet, almost understated resemblance to Earth. With a mass roughly 1.7 times our planet's and a density suggesting a rocky composition, GJ1061c is the Goldilocks middle child of its system. Not too big, not too small, but potentially just right for life as we know it. Yet its charm lies in the challenges it presents, because studying this world is like trying to read a book by candlelight while standing in a hurricane. The star at the heart of this system, GJ1061, is a red dwarf so faint it emits less than 1% of the Sun's visible light. For a planet like GJ1061c, orbiting this dim ember every 13 days, the term habitable zone takes on new meaning. Here, the boundary between frozen wasteland and temperate oasis is razor-thin. A slight nudge inward and the planet bakes, a nudge outward and it freezes. Yet models suggest GJ1061c might thread this needle perfectly, receiving just enough warmth to keep water liquid, if it can cling to an atmosphere, and that's the rub. Red dwarfs like GJ1061 are notorious for their violent youth, bombarding nearby planets with radiation that can strip away atmospheres over eons. If this planet's air survived that onslaught, it would need to be dense and resilient, perhaps rich in carbon dioxide to trap every scrap of stellar heat. Detecting that atmosphere, though, is like listening for a whisper in a thunderstorm. Current telescopes struggle to analyze the chemical fingerprints of planets around such faint stars, especially when the planets don't transit, meaning they don't pass in front of their star from our vantage point. GJ1061c is one of these elusive, non-transiting worlds, discovered through the subtle wobble it imposes on its star rather than the shadow it casts. This makes studying its atmosphere exponentially harder, requiring indirect methods like analyzing reflected starlight, a feat only next-generation telescopes might achieve. Yet the effort is worth it. GJ1061c represents a quiet revolution in exoplanet science, the realization that some of the most Earth-like worlds might orbit stars utterly unlike our Sun. Its compact orbit could even work in its favor. Tidal forces from the star might keep the planet's interior warm, driving geologic activity that recycles atmospheric gases, a process critical for maintaining habitable conditions over billions of years. Imagine a world where volcanoes periodically replenish the air, where geothermal vents bubble beneath ice-covered oceans, and where the faint glow of its star paints the landscape in perpetual twilight. The real intrigue lies in what we can't yet see. If GJ1061c has an atmosphere, future instruments might detect the faint traces of water vapor or methane, hints that this unassuming world is more than just a rocky shadow. But even if it's barren, its existence whispers a tantalizing truth, that planets like Earth might lurk around even the humblest stars, hidden in the cosmic back alleys of our galaxy. GJ1061c doesn't dazzle with flares or drama. It simply endures, a quiet testament to the universe's knack for crafting familiarity in the most unexpected places. Kepler 438b should have been the perfect Earth twin rocky, just 12% larger than our planet, and orbiting snugly in its star's habitable zone where liquid water could flow. But this world, 500 light-years away in the constellation Lyra, hides a dark secret. Its red dwarf sun is a cosmic bully, unleashing violent flares hundreds of times more powerful than anything our sun produces. These eruptions aren't just occasional tantrums, they're frequent, apocalyptic events that blast the planet with radiation capable of stripping atmospheres down to bare rock. Studies suggest Kepler 438b may have lost its protective air long ago, leaving its surface exposed to a relentless assault of X-rays and charged particles, a death sentence for life as we know it. Yet beneath this hostile surface, another story might be unfolding. Imagine vast networks of caves and underground aquifers shielded from the radioactive barrage above. On Earth, microbes thrive in places like Lechuguilla Cave, where sunlight never reaches and survival depends on chemosynthesis, harvesting energy from minerals rather than light. If Kepler 438b retains even a fraction of its original water, those reservoirs could have retreated underground, pooling in labyrinthine chambers warmed by geothermal heat. Tidal forces from its close orbit might keep the planet's core active, driving hydrothermal vents that recycle nutrients through these hidden oceans. Life here wouldn't just adapt to the darkness, it would embrace it, evolving to exploit every crack and fissure where warmth and chemistry intersect. The planet's star adds another twist, While younger red dwarfs rage with instability, Kepler 438 has aged into relative calm, meaning the worst flares might belong to its past. If the planet's atmosphere eroded early, any surviving organisms could have had billions of years to adapt to the new normal. Picture extremophiles that repair their DNA with eerie efficiency, or colonies of organisms linked in vast subterranean networks, trading resources through slow, cold-resistant metabolisms. Even surface life isn't off the table. Some earthly lichen, like Xanthoria elegans, can survive space's vacuum and radiation. On Kepler 438b, similar organisms might cling to shaded mountain crevices, emerging during lulls in stellar activity to harvest trace moisture from the thin, residual air. The tragedy and the hope of this world lies in its duality. By all surface measures, it's a cautionary tale. A planet so battered by its star that even its position in the habitable zone feels like cruel irony. But dig deeper and Kepler 438b becomes a masterclass in resilience. It challenges us to redefine habitability, proving that life's survival might depend less on a star's kindness and more on a planet's ability to hide, adapt, and endure. Future telescopes could search for indirect clues, geothermal hotspots, or chemical imbalances in any lingering atmosphere, but for now, this world remains a haunting question mark. A reminder that even in the ashes of stellar fury, life might still find a way. HD 85512b lurks on the razor's edge of possibility, a world where the line between paradise and pressure cooker blurs under the glare of an orange dwarf star. Discovered just 36 light-years away, this super-Earth tips the scales at 3.5 times our planet's mass, with gravity strong enough to make every step feel like wading through syrup. But what truly sets this planet apart is its precarious perch nestled just inside the inner boundary of its star's habitable zone, where temperatures teeter between balmy and brutal. Picture a world where the air hangs thick with humidity, where storms brew in slow motion under a sun that appears larger and more amber than our own, casting everything in a perpetual golden haze. Climate models paint HD 85512b as a potential greenhouse jungle, its dense atmosphere trapping heat like a planetary sauna. While Earth's tropics hover around 80 degrees Fahrenheit, this world's surface could simmer at 140 or higher temperatures that would boil away Earth's oceans but might forge entirely new ecosystems here. Imagine forests of towering heat-resistant flora, their leaves waxy and reflective to bounce back the intense sunlight, or shallow, hypersaline seas where extremophiles thrive in waters as hot as a jacuzzi. The planet's star, HD 85512, emits a gentler ultraviolet glow than many red dwarfs, offering a rare sanctuary where an atmosphere could persist despite the heat. That's the gamble. If the planet's air is rich in reflective cloud cover or high-altitude haze, it might mitigate the stellar onslaught, creating microclimates where liquid water could pool in shaded valleys or highland mist forests. The irony, this world's extremes might be its salvation. On Earth, tropical rainforests are biodiversity hotspots precisely because their relentless heat and moisture accelerate chemical reactions, the very engines of life. HD 85512b's supercharged metabolism could birth organisms that make Earth's thermophiles look frail. Creatures with proteins stabilized by exotic chemistries or cellular machinery built to harness thermal energy directly. Some astrobiologists speculate that such environments might even favor larger, more complex life forms, as higher temperatures could speed up evolutionary timelines. Yet the planet's true test lies in time. HD 85512 is billions of years older than our Sun, meaning this world has endured eons of stellar evolution. If its atmosphere survived the star's volatile youth, it could have settled into a stable, if sweltering, equilibrium, a glimpse of what Earth might become as the Sun ages and brightens. Future telescopes could hunt for biosignatures like methyl chloride, a gas produced by tropical plants on Earth, or signs of cloud patterns hinting at active water cycles. For now, HD 85512b remains a siren song for astrobiologists, a world where life, if it exists, wouldn't just adapt to the heat, it would rewrite the rules of biology to thrive in it. Kepler 296e offers a spectacle unlike anything in our solar system, a world where the sky is shared by two suns, casting shifting, kaleidoscopic light across its surface. This planet, part of a rare binary star system, orbits the primary star Kepler 296a, while its companion star Kepler 296b looms in the distance like a fiery sentinel. Imagine standing on this alien world, watching as the two stars dip below the horizon in a staggered dance, painting the clouds in hues of gold, crimson, and violet. The primary sun, larger and brighter, would dominate the daytime sky, while its smaller, dimmer companion might appear as an intense glowing ember, sometimes close enough to cast faint shadows, other times vanishing into the glare of its sibling. The light here is anything but constant. As the stars orbit one another, their combined illumination waxes and wanes, creating days where the brightness fluctuates like a slow-motion pulse. For Earth's ecosystems, sunlight is a steady drumbeat, but on Kepler 296e, life would evolve under a symphony of shifting intensities. Plants, if they exist, might develop leaves that adjust their angle throughout the day, tracking the brightest star or spreading wide during periods of dimmer light to soak up every precious photon. Photosynthetic organisms could evolve to harness a broader spectrum, their pigments ranging from deep blues to absorb the primary star's white-yellow light to rich reds tuned to its cooler companion. Picture forests where the foliage shimmers with iridescence, adapting in real time to the ever-changing skies above. Then there's the climate. Binary stars tug at their planets with competing gravities, potentially stretching and squeezing orbits over millennia. Kepler 296e's path might be more elliptical than Earth's, leading to subtle but impactful seasonal shifts. During periods when the planet swings closer to both stars, temperatures could rise, melting ice and swelling rivers. Farther out, the world might cool into a brief winter unless its atmosphere is thick enough to buffer these changes. A dense blanket of greenhouse gases could smooth out the extremes, creating a stable, if dynamic, environment where life clings to equilibrium. The true marvel of this system lies in its contrasts. While one side of the planet basks in perpetual daylight thanks to the stars' staggered positions, the other might experience a truer night, albeit one occasionally pierced by the companion star's faint glow. In the twilight zones between these extremes, life could thrive in niches unimaginable on Earth, organisms that hibernate during darker cycles, or creatures with bioluminescent displays tuned to the star's rhythms. Even the tides would defy earthly logic, pulled by two gravitational sources in a complex, overlapping cadence. Kepler 296e challenges our Earth-centric notions of habitability. It's a world where life wouldn't just adapt to one sun, but to two, where evolution writes its rules in dual light sources, and where the sky itself is a canvas of endless variation. As we study systems like this, we're reminded that the universe's creativity knows no bounds. A planet like this isn't just a candidate for life, it's a laboratory for reimagining what life could be. Gliese 581g is less of a planet and more of a cosmic ghost, a world that might exist or might not, depending on which astronomer you ask. Discovered in 2010, this exoplanet sparked instant controversy when researchers announced they'd found it orbiting comfortably in the habitable zone of its red dwarf star, 20 light-years away. The initial excitement was electric. Here was a rocky world, possibly 3 to 4 times Earth's mass, with just the right temperatures for liquid water. Headlines declared it the first potentially habitable exoplanet, but the celebration was short-lived. Within months, other teams scrutinizing the same data couldn't replicate the finding. The planet vanished as quickly as it had appeared, or at least it seemed to. The heart of the debate lies in the detection method. Gliese 581g was discovered using radial velocity, a technique that measures the subtle wobble of a star as planets tug on it. But red dwarfs like Gliese 581 are temperamental. Their surfaces roil with starspots and flares, creating noise that can mimic planetary signals. The original team, led by astronomer Stephen Vogt, stood by their data, insisting the planet's gravitational signature was real. Yet when the HARPS team, using a rival instrument, reanalyzed the star's wobbles, they found no trace of Gliese 581g. The astronomy community split down the middle, with some calling it a groundbreaking discovery and others dismissing it as stellar activity masquerading as a planet. The stakes couldn't be higher. If Gliese 581g is real, it's a textbook Goldilocks world, neither too hot nor too cold, with conditions that might resemble Earth's temperate zones. Models suggest it could be tidally locked, with one face forever turned toward its dim red sun and the other shrouded in eternal night. But that doesn't rule out habitability. The Terminator line, the border between light and dark, might host a band of perpetual twilight where temperatures hover near freezing, yet liquid water could persist in insulated pockets. Imagine towering glaciers creeping toward sunlit valleys, their meltwater feeding rivers that snake through rugged highlands before evaporating under the faint crimson glow. Yet the absence of consensus leaves Gliese 581g in limbo. Over a decade later, the question remains unresolved, a testament to the messy human side of science. Newer studies occasionally resurrect the debate, with some analyses hinting at weak signals that could correspond to the planet, while others argue the entire system's architecture makes Gliese 581g's existence statistically unlikely. The James Webb Space Telescope might finally settle the argument by imaging the star system directly. But for now, this world lingers in a Schrödinger's box of astronomy, both there and not there, its status a mirror of our own uncertainties. What makes Gliese 581g so compelling isn't just the science, it's what it reveals about how we explore the cosmos. Discovery isn't always clean or linear. Sometimes it's a battleground of interpretations where the line between noise and revelation blurs. Whether this planet exists or not, its ghostly presence has already reshaped our approach to exoplanet hunting, teaching us to question, verify, and above all, embrace the unknown. In the end, Gliese 581g isn't just a world. It's a reminder that the universe keeps its secrets well, and that the search for answers is as thrilling as the answers themselves. Kepler-22b holds a special place in the history of exoplanet science, not just as another world in the habitable zone, but as the first one we ever confirmed. Imagine the excitement in 2011 when NASA announced its discovery, a planet 2.5 times the size of Earth, orbiting a sun-like star 600 light-years away, with a year 290 Earth days long and temperatures that, at least on paper, might allow liquid water to exist. This wasn't just another data point in a growing catalog. It was proof that planets like ours could, and did, exist around stars like ours. But what makes Kepler-22b truly fascinating isn't just its historic status, it's the enduring mystery of what it actually is. The planet's radius places it in a cosmic gray zone, too large to be purely rocky like Earth, yet too small to be a gas giant like Neptune, the leading theory. A water world, a globe spanning ocean hundreds of miles deep, capped by a steamy, hydrogen-rich atmosphere. Picture an endless seascape where the very concept of land is alien, where storms churn waves the size of continents, and where the ocean floor, if it exists at all, lies under crushing pressures that turn water into exotic forms of ice. The star it orbits adds another layer of intrigue. Kepler-22 is slightly smaller and cooler than our Sun, but it's remarkably stable, with none of the violent flares that plague red dwarf systems. That stability would give any potential atmosphere or ocean a fighting chance to persist over billions of years, yet the planet's distance from its star is a tightrope walk. Sitting just 10% closer to the inner edge of the habitable zone than Earth does, Kepler-22b's climate would depend critically on its atmospheric composition. A thick blanket of greenhouse gases like carbon dioxide could trap enough heat to keep the oceans liquid, while a thinner atmosphere might leave it as a frozen snowball with only subsurface seas. The legacy of Kepler-22b extends far beyond its own hypothetical oceans. Its discovery marked a turning point in exoplanet research, proving that the Kepler Space Telescope's mission wasn't just about finding planets, it was about finding possible homes. Before this world, the habitable zone was a theoretical concept. Afterward, it became a tangible frontier. Kepler-22b forced us to confront the diversity of habitable environments, challenging the assumption that Earth-like meant Earth-sized. A planet could be a waterlogged super-Earth, a steamy mini-Neptune, or something entirely unforeseen, and still, just maybe, cradle life. Today, as newer telescopes probe deeper into exoplanet atmospheres, Kepler-22b remains a touchstone. It reminds us that habitability isn't a checklist but a spectrum, a delicate interplay of star, planet, and time. Whether this world is an aquatic paradise or a pressurized hellscape, its true gift was opening our eyes to the universe's boundless creativity. The first confirmed habitable zone planet didn't just expand the map of the cosmos. It rewrote the rules of the game. From crimson-lit Kepler-186f to the binary star ballet of Kepler-296e, these 25 worlds have taken us on a tour of cosmic possibility, each rewriting the rules of what makes a planet habitable. We've wandered water worlds shrouded in steam, scaled super-Earths with crushing gravity, and peered into the twilight bands of tidally locked oddities where day and night are frozen in place. Some orbit calm red dwarfs that have burned steadily for billions of years. Others dance with flare-prone stars that periodically scorch their surfaces. A few, like Gliese 581g, hover at the edge of detection, reminding us that every answer in astronomy comes with a trail of new questions. What unites them isn't just their potential for liquid water, it's their staggering diversity. Habitability isn't a checklist, it's a spectrum. A planet like K2-18b proves life might thrive in a hydrogen-rich sauna, while LP-899c suggests even ultra-cool stars could cradle temperate oases. Teegarden's star B whispers that darkness doesn't mean lifelessness, and HD 85512b dares us to imagine biology that flourishes in a pressure cooker. These worlds defy our Earth-centric assumptions, showing that life, if it's tenacious enough, could adapt to almost any niche the universe carves out. The future of exoplanet exploration is brighter than ever. Telescopes like James Webb are already dissecting alien atmospheres, hunting for molecular fingerprints of water, methane, or even industrial pollutants. Missions like Habitable Worlds Observatory aim to directly image Earth-like planets, while projects like Breakthrough Starshot dream of sending probes to our closest neighbors. Every discovery peels back another layer of the cosmic onion, revealing not just new planets, but new kinds of planets. Who's to say we won't find a world with floating silica-based life forms in its clouds, or a subsurface ocean lit by geothermal auroras? So here's your invitation. Look up tonight and pick a star, any star. Maybe it's Proxima Centauri, where a rocky world just 4 light-years away might host alien tides. Or Kepler-452b, a vision of Earth's far future under an aging sun. Imagine the civilizations that could be gazing back, the creatures swimming in pitch-black seas, or the slow-growing forests basking in eternal twilight. The universe isn't just stranger than we imagine, it's stranger than we can imagine, and the best part, we're just getting started. If these cosmic stories sparked your curiosity, there's plenty more where they came from. Hit subscribe to join us on the next leg of this interstellar journey, because the hunt for alien Earths is far from over, and the next big discovery might be just one telescope glance away. After all, in a galaxy with billions of planets, the real question isn't whether we'll find life elsewhere, but what we'll find, and how utterly it will reshape our place